The early days of a new project are exciting. You're moving quick, you're discovering your game, but a few years on, it can start to feel like this hulking, brittle mass that's slow to work with and easy to break. You fall out of love with your game, and after 4 years working on Farewell North, even just opening the project felt like a huge hurdle some days. The longer a project goes on, the more inevitable it is that you kind of start to resent working on it. But there are a few ways you can help yourself out and maintain your sanity. What's so exciting about the early days of a project are all the possibilities. You're not burdened by years of decisions, you're making the decisions, you're calling the shots. In these early days, you're really establishing the rules of your project that you'll live by in the years to come. For example, maybe this sounds familiar. You're setting up the first door for your new game. So you decide that every door needs a kinematic rigid body and a box collider, plus 2 trigger sensors to tell when the door is safe to open, and the trigger sensors need to be on the sensor layer, while the box collider must be on the environment layer. Oh, and there needs to be a nav mesh obstacle set to carve. Oh, and of course, under no circumstances should the door ever have the occluder static flag set. It doesn't really matter what these rules are, but you know the feeling, right? Every object you set up is establishing all of these little rules and this cognitive overload that you're adding to your project. And it's a lot to remember. And one day, a few months or years down the road, you'll say to yourself, what do these trigger colliders do? Why is the rigid body on the environment layer? It would really help if it were on the geometry layer. And worse, you'll make changes without even remembering that there was an important rule there in the first place. One day you'll decide that you want to set the occluder static flag on all your environment prefabs, completely forgetting that doors must never have that. Suddenly things aren't working quite right, bugs are spreading up in areas that have worked fine for years, and you start to ask yourself how any of this was ever working in the first place. You could write documentation and comment your code, but let's be honest, are you ever going to read it? This is where validators come in. The simplest form of these is just using the onValidate function provided by Unity and adding assertions. If the assertion fails, it'll log an error message in the console so you can fix it right away. Oh, and bonus tip, always keep the editor pause flag enabled to pause the game when an error is logged and fix any errors that pop up. Don't just let them pile up, that is such a bad practice. So you can use onValidate for quick checks, but a more generic and reusable approach is with a validator class. I start with a base class which has a target property set to either target all of the validator's children or every object in the scene. It then runs through the hierarchy and calls an abstract run validation function on every game object. It's then up to the implementing class to decide what the validation actually is. For example, I have a layer validator which ensures that every object is on a specific layer, and a static validator which ensures that every object has the correct static flags. These are simple, reusable, generic rules that help in every project, but I also get more specific to the way that I make games. For instance, I know that for every LOD group I create, I have a few rules. Rule number 1, there are no renderers that are not part of the LOD group. Rule number 2, there are no null renderers in any of the LODs. And rule number 3, if there's a renderer set to render shadows only, all the other renderers in the group should have shadows set to off. Again, the rules aren't important. What's important is they're how I like to define LOD groups. So I set up a validator to find every LOD group in the scene and ensure that the rules are being followed. If not, I get an error message telling me, hey, this LOD group isn't set up correctly, here's why. It took an hour to write this logic a few years ago, and it saved me countless times over the course of 2 games. Now, I don't recommend creating tons of these, that just becomes a lot of noise, but you can gain a lot of stability with a few simple reusable validators that let you say, everything in this scene or this group of objects should be set up a certain way. Now, I already know that this next one's going to be controversial, but hear me out. A simple guideline for how good your game is going to be is simply how many times you can iterate on it. So it stands to reason that the quicker you can load into your game, the more often you'll do it, the more iterations you can make, and the better your game will be. There's a mindset you see sometimes that just because something is only going to run in the editor, performance doesn't really matter. And I think that's ridiculous. You're going to spend hundreds or even thousands of hours working on your game, and the more of that you spend waiting for the editor, the less you can spend making your game better. Now, you certainly shouldn't obsess over editor performance, but once in a while, just profile the editor, especially when you find certain tasks like starting or stopping the game are getting really slow. A lot of the time, there's some quick wins to be had, which will make the editor feel a bit snappier, and it might even help make your game load quicker for players too if you find that it's something in your game logic that's taking a long time to get warmed up, like slow awake or start functions. Worst case scenario, you'll learn a thing or two about what your engine is doing, which is always helpful. Now, if you're using Unity, there's one quick tip which will save you tons of time. Disable domain reloads. By default, Unity reloads the domain each time you click play, which effectively resets static fields and events, but it's very slow, and if you're careful to maintain your static state properly, then it really isn't needed anyways. Disable this, save a bunch of time, make a better game. Of course, some algorithms are just really slow, like making light maps or occlusion culling, but just because it's okay for those specialized tasks to be slow, doesn't mean we should be okay with all of our time in the editor being slow. Get comfortable in the profiler for both your game and your editor, and save yourself some time and sanity in the long run by tightening up those slow editor behaviors. Understanding the maths behind these algorithms can go a long way to helping you optimize them, and a great way to learn is through the sponsor of this video, Brilliant. See, Brilliant helps you excel in math and coding with step-by-step interactive lessons and personalized practice. You learn by doing, by actually solving problems, not just watching videos. Their courses are crafted by world-class teachers from MIT, Harvard, and Stanford, and they're designed for anyone from ages 10 to 110. I use Brilliant to refresh the math skills that I haven't really practiced in years. I'm currently 70 days in on the calculus course and finding it super helpful. It's a lovely way to start my day, and I honestly feel like I understand the topic better than I ever have. I'm excited to jump into the algorithmic thinking course next, which teaches you the fundamentals of designing algorithms. You guys know that's a topic I love, and an algorithmic mindset goes a long way in building efficient and optimized features for your game. To learn for free on Brilliant for a full 30 days, go to brilliant.org/KyleBanks, scan the QR code on screen, or click the link in the description. Brilliant's also giving you guys 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Speaking of algorithms, once you've been making games for a while, you'll probably start to find you've designed a few tools and algorithms that you really love. What you want to do is start to assemble your core library of generic tools and scripts, things that you'd want to have in any new game that you start. For example, in Feral North, all the logic used to tell an NPC to walk over there, trigger the walk animations in the nav mesh logic, and then have them say a line of dialogue with subtitles depending on the user setting, that's all core library stuff which comes with me from game to game. However, the logic for sheep herding and color restoration is very specific to Farewell North. It wouldn't really be generally useful for any old game, so that stuff stays in the Farewell North directory. What I do for every game is split my scripts into two folders, one for my core library and one that's game specific. My biggest rule here is that the game folder can import from the core library, but the core library cannot import from the game folder. And I actually enforce these rules with assembly definitions, meaning if I try to import something from the game folder into the core library, the game won't compile. Now the benefit to this is that you're investing in yourself long term, and all the testing, the lessons, the bug fixes that went into it on game 1 carry over onto game 2, 3, 4, and so on. I keep this core library as its own subrepo in Git, and I'm very meticulous about keeping it well structured, well documented, and generic as possible. I don't write shit code in the game specific folder, but I consciously try not to over-engineer things when I'm aware that it's only for one game. I invest in the core library, and I focus on getting things done in the game scripts. As we've discussed, the more you can iterate on your game, the better it will ultimately be. Knowing this, help yourself out a bit with some test tooling. I have this checkpoint and trigger UI, which I include in each project as part of my core library. It helps me jump ahead to any checkpoint in the game without having to set up any data. Sometimes you need to test a very specific situation which requires certain save data, so for that I keep a core library of save files in Notion so I can quickly jump to any of these special saves. Believe me when I say it can be utterly soul-destroying having to spend 5, 10, 20 minutes setting up a test case for the 100th time. Years into a project, you will be so sick of it that the thought of spending even 5 minutes testing something will feel insurmountable. So the more you can help yourself out here, the better. These tools don't have to be pretty, but do keep in mind you can also give these to playtesters, QA, trailer editors, really anyone you're working with to make their lives easier, and the easier you make their lives, the better your game will be. Okay, let's run through a few more rapid fire tips. Similar to the validators, sometimes you just need to help yourself out a bit. There's probably a better way to do this with an asset or something, but a nice, quick, easy, and free way to go is just to add a notes class with a text field and an optional object reference that you can attach to any game object. I like to use this to leave reminders to myself, typically only when there's something really weird about a certain setup that goes against my normal way of doing things. Or maybe if it fixes a particularly strange bug. In the entire Farewell North project, there are only maybe a dozen of these. You want to use them sparingly, but it can be a big help. Just a nice little gentle assist for yourself. If I had access to your computer and I randomly deleted a whole bunch of files from your project, how screwed would you be? Set up source control and use it religiously. Using source control doesn't just save you from disasters, it also lets you be more experimental. Try big, breaking changes without worrying about blowing up your project. You can create a branch, experiment, and then either discard or keep those changes depending on how your experiment went. If you're finding that you're afraid of trying things because it could break the project, you really need to put more effort into your source control. Again, this one might be a bit controversial, but hear me out here. If you release your game and you find that's crashing on certain setups because one of your plugins doesn't support it, guess who players are going to blame? Every asset you add to your project means you're committed to dealing with all of its shortcomings, whether that's updating it when you update your engine, porting it if you need it to run on consoles, optimizing it if you can't hit your target frame rate, all of that fun stuff. So many plugins on the Unity Asset Store have horrible code which will impact the performance of your game, but with a few quick tweaks can be greatly improved. And I'm talking about really basic stuff too, like allocations or reference management in update loops, finding objects by name, really low-hanging fruit that you can easily benefit from fixing just by having a quick nose through the plugin. Assets are meant to save you time, but spending a few minutes going through the code and assets to understand how they work, tidying up any kind of shortcomings, can be a big help before it's too deeply embedded into your project. I also do a little bit of housekeeping, removing any unused portions of the assets, especially demo scenes and demo models when I'm done with them, because it just bloats your project and adds to the general slowness as your project grows. If it's not being used, get rid of it. You can always re-download it from the package manager later. So let me know how long you've been working on your project and any tips you found along the way to give yourself a helping hand down below. Thank you to all my patrons who support this channel, and an extra special thank you to my Ospreys Elagon, Jason Hansen, Ellie Swaley, Justice Lind, Brandon Pung, Peter James, Will Todd, Neil Blakey Milner, Peter Randall, Jason Lin, Alan Halstead, Josh Temple, and Chris. Thank you so much for watching. If you haven't noticed, my throat is absolutely killing me, so I'm going to go lay down, but I will see you guys next time.